So for the first section, it's kind of just like a review. Y'all just took the quiz over arithmetic and geometric, but you will have sections where you have to identify and determine if it's arithmetic or geometric, so that's why I threw these in here. If I am looking at -4, 12, -36, and 108, if that is my sequence, can you look at that and determine if it's arithmetic or geometric?
Geometric.
Geometric. What is the biggest hint for it to be geometric?
It switches the letters.
Mm-hmm. So you're alternating positive and negatives. So that will never ever be arithmetic, okay? So here it's going to be geometric. So I need my A1 and my common ratio. Well, my A1 is -4. My ratio, I'm going from -4 to 12. What happens there? What am I multiplying by?
-1, 2.
I'm getting bigger, so it would be -3. Okay? So my equation would be AN is equal to
-4 minus 3 times parentheses and -1.
okay, so -4 times
Oh, right,
-3 raised to the n minus 1. Yes?
That makes sense.
Okay. So then this next one, 4, 13 thirds, 14 thirds, 5. If I can recognize what's happening right here, then I'm going to double check, put this in fraction form, make sure that continues the pattern. So from 13 thirds to 14 thirds, I'm adding 1/3. So 4 as a fraction over 3 would be 12 thirds, and 5 would be 15 thirds. If I were to convert that, does that follow adding 1/3 each time? Yes, so it's arithmetic. My common difference is 1/3. Okay, I'm going to find my A0 by subtracting my A1, 12 thirds, minus my difference, 1/3, and that leaves me with 11 thirds. So my equation would be AN is equal to my DN, 1/3 N, plus 11 thirds. Okay? So hopefully you'll recognize the difference between arithmetic and geometric. Arithmetic has more of a linear equation. Geometric has your n as your exponent. Okay? Because it's similar to exponential. So we're going to look at series now, not just sequences, but series. So an arithmetic series is the expression formed by adding the terms of an arithmetic sequence. The sum of the first n terms of an arithmetic series is denoted by S with a little subscript n. So that's the formula for the sum of an arithmetic series. Okay? Now, I'm either going to give you the series or I'm going to give you this summation notation. Okay, this is called sigma. It's a Greek letter. All it represents is summation. You're adding terms together. Okay, so it looks a whole lot different than what you're used to. This is your first time to probably see it. All it means is that we're adding it all together. Okay, so the template of summation notation is I'm going to have k equals a number. Okay, that number is your beginning value. Then you're going to have a number, say just one single number. It could be 5, it could be anything. Okay, that's your ending value. So that's telling you you're adding the terms from this beginning term to this cutoff point, if that makes sense. And then your rule is basically the equation for the arithmetic sequence. Okay? So we know what our A1 is, first term. AN is technically our last term now. And then N is the number of terms. So if I'm looking, I'm giving you summation notation. And I'm asking what is a sum. So 1 will be my starting value of k, and then I'm going to stop at my 20th term. Okay? And then my equation is 4 plus 3k. So we need to find the first term first. So I'm going to find my A1 by plugging in 1 for that k. So it's going to be 4 plus 3 times 1, which is 7. Okay? My last term means I'm finding whatever this is. So I'm going to find a 20. 4 plus 3 times 20. That's going to give me 64. Okay? From here, we need to know how many specific terms. Okay? Just because this says 20 isn't going to guarantee that's the n every single time. Meaning, sometimes, like this next example, I'm not starting at 1. So you're going to have to consider how many terms you actually are adding up. For this case, because I start at 1, I'm going from 1 to 20, my n is 20, but not every single time. Okay? So if I'm going to plug all of this into this formula, I've got Sn, well, it's not n, it's 20. S20 is equal to, replace the n with 20, parentheses, the value of my first term is 7, plus the value of my last term is 64, all divided by 2. Alright, you can type that exactly as you wrote it in your calculator. You've got 20 parentheses, set up your fraction, 7 plus 64 over 2 gives me 710. So my sum for those 20 terms is 710. It's a matter of memorizing your formulas, okay? Because you're going to have 3 different formulas in today's lesson. Okay, so you've got to memorize them. Here, I'm going from my 4th term to my 12th term. My equation is 2 plus 7k. Okay, so my A1 isn't really A1, it's A4. So 2 plus 7 times 4 is what? 30. And then I'm going to find A12. 2 plus 7 times 12. Okay. Now if I'm going from 4 to 12, what's my n? What's my number of terms? 4, 5, 6, 7, 8, 9, 10, 11, 12. 9. So really, you could subtract and then just add 1 because you have to take consideration that 4. Okay? So my n is equal to 9. So my formula, if I use it, S9 is equal to 9 times 30 plus 86 over 2. So you should get 522. Y'all good with that? Do we have questions? Okay. Okay, now this next example, I give you the sequence or the series. I don't give you summation notation. So we have to come up with the rule and the equation, okay? I know it's arithmetic, so if I'm going from 34, even though it's 34 plus 30 plus 26, imagine it as if those were separate terms, okay? So 34 to 30, what did I do? Subtract 4, so that's my common difference, minus 4. My A1
34.
is 34. I can find my A naught. What would have come before 34? 38. So I can actually come up with the equation AN is equal to negative 4N plus 38. Okay? What I don't know is how many terms is it actually from 34 all the way down to 2. Okay? So that's what we need to figure out. Well, we can figure that out by plugging in our 2 for our AN. Okay, so we need to solve for this n. So I'm going to have 2 is equal to negative 4n plus 38. Subtract your 38, you get negative 36 equals negative 4n. Divide by negative 4, n is equal to 9. Okay? So, if you want to write it in summation notation, you can. You don't have to if you know your formula. But summation notation would be k is equal to 1, and then I'm going to 9. That should have been in the middle. I'm going to 9. And then my equation, instead of an n, I've got a k, so it's negative 4k plus 38. You do not have to do this. But if you are a visual person and you need to see it in that form to be able to do your formula, that's fine. Our formula is just S9 is equal to 9. And then you take 34 plus 2, divide it by 2. And that should give you, if you type it in, 162. You're good with that? Okay, that's arithmetic. So geometric series is the expression formed by adding the terms of a geometric sequence. This is your new formula for that. So the formula we just used, ignore that for geometric. Okay? Now this is going to be a finite geometric series, meaning you have a beginning and you have an end. Just like what we did with arithmetic, you've got a beginning and you've got an end. Geometric, there's two different ways. You've got a finite series and you've got an infinite series. Okay? So this is the rule for a finite geometric series. So you've got Sn is equal to A1 times 1 minus r to the n power over 1 minus r, where r cannot equal 1. So you need to find the first term, you need to identify the common ratio, you need to identify how many terms there are, and then plug it in and find the sum. Okay? So if this example has your rule 4 times 3 to the k minus 1, I'm starting at 1 and I'm going to 16. So how many terms, what's my n?
I mean, A1 is
A1 is 4, what's my n though? 16. Now remember, for geometric, my formula was an is equal to a1 times r to the n minus 1. So your a1 is whatever comes in front of your parentheses. Okay? So for this situation, my a1 is 4. Okay? So if I'm plugging it into my formula, I've got S16 is equal to 4 parentheses 1 minus my r is 3 to the 16th power over 1 minus 3. Type that in your calculator exactly as you see it. You can do it all. So 4 parentheses, get your fraction template. 1 minus 3 raised to the 16th over 1 minus 3. Gives you a very big number.
86 million something.
Yeah. Which, if you think about it, a geometric, yes. Well, your rule is only your n, your number of terms. So if you think about geometric resembles an exponential, that should be a pretty large number because you're growing exponentially. Okay? If you want to relate the two, you should have a very big number. Okay? I didn't put multiple examples for a finite series because you're just going to keep doing the same stuff like we just did with arithmetic. Okay? Do you understand the formula to plug everything in? Okay. So for an infinite geometric series, the sum of the first n terms of an infinite geometric series is called a partial sum. The partial sum of an infinite geometric series may approach a limiting value. The sum with the first term a1 and common ratio r is given by this formula. So this is your third formula you have to know. Your sum is a1 over 1 minus r. Now you've got a restriction on your r, your ratio. If the absolute value of your ratio is greater than 1, you have no sum. Okay, that's a rule you're going to have to memorize. Some things in math you just have to memorize. Okay, so that's going to be one of your rules. So I'm going to put that formula, your sum is a1 over 1 minus r. Okay, so here is my rule. I've got summation notation. So instead of having a specific term, it's going to go to infinity. Okay, that's how I know it's an infinite. The dot, dot, dot is how I know it's going to be infinite versus finite. Okay? So I need to know my A1 and my R. What's my A1? What's my R?
4.
Okay. Is that greater than 1? No. So I'm good to go. So I can find the sum. I've got 5 over 1 minus 4/5. As long as you can show me plugging in the correct stuff, you can type that in your calculator. Okay? 5 divided by 1 minus 4/5 should give you 25.
That was infinite though, so why do you add a number?
It's a partial sum. So you'll get more into partial sums and all that next year. So if I have 1 minus 3/4 plus 9/16 minus 27 over 64, that's the same thing. Consider that like separate terms. Okay? So I know what A1 is. A1 is 1. I need to know what my ratio is. Well, my ratio from 1 to negative 3/4 is what? Negative 3/4. If I didn't start with 1, how could I find my common ratio?
You would have to divide.
Second divided by first. Okay? So here my sum, if I were to take the absolute value, before I even start plugging stuff in, if I were to take the absolute value of 3/4, is that greater than 1?
No.
No, so I can do it. So my sum is my 1 over 1 minus negative is going to turn into a plus 3/4. Type that in your calculator and you should get 4/7. Okay. So then my next example, 3, negative 6, 12, negative 24. My A1 is 3. My ratio,
Negative 2.
Oh wait, no, that's too much.
so if I were to take the absolute value of that,
That's
Just
just
choose
greater than 1.
No sum.
yep, so it would be no sum.
Oh, no, Einstein, no solution.
So there would be no sum for that. Okay?
Oh, that's everything.
Do y'all have any questions?
Yeah, go on. Did you have a good one?
I did. Yes. Thank you for asking.